Welcome to our channel. The aftermath of the 3I Atlas flyby promises to reshape astronomy. We are on the cusp of a new era of discovery. The upcoming Vera C. Rubin Observatory is scheduled to come online soon. Its powerful telescope is expected to find dozens, perhaps hundreds, of similar interstellar visitors. The strange case of 3I Atlas will no longer be a singular curiosity. It will be the first of a new class of objects to study. Its anomalies may become the new normal. Or it may forever remain the one that got away, the most mysterious visitor of all. For now, the story continues. You can be a part of it. The adventure of tracking 3I Atlas in real time is open to everyone. Resources like NASA's Eyes on the Solar System website allow anyone with an internet connection to follow its path. You can watch as it moves away from the Sun. You can see its projected course out of our solar system, back into the interstellar void. It is a silent envoy from a realm we are only beginning to explore. Its final secrets are still locked within its dark, traveling heart. The chapter is not yet closed. The data is still streaming in. And the whole world is watching, waiting for the next clue in the greatest detective story in the cosmos. The world held its breath in early December. All eyes, both human and robotic, were fixed on the red planet. The Mars Reconnaissance Orbiter's high-rise camera, capable of resolving objects the size of a kitchen table from orbit, was perfectly positioned. For a critical 48-hour window, it captured a burst of high-resolution images as 3I Atlas streaked past at a distance of just over 4 million miles. The first processed images landed in the science team's inboxes. A collective, digital gasp echoed across the globe. The object was not the lumpy, potato-shaped rock everyone had expected from previous asteroids and comets. It was long and thin. The press release from the mission team, carefully worded, described it as an elongated, irregular shard. But the raw images told a more dramatic story. It looked like a splinter. A cosmic dagger. Its surface was unnaturally dark, with an albedo lower than charcoal, absorbing almost all sunlight that hit it. And along one edge, high-rise had caught a glint, a sharp, geometric reflection that suggested a flat, polished surface. The shard from the void headline wrote itself. This new data poured gasoline on the debate. The artificial origin camp, emboldened by AVI Lab, pointed to the object's geometry. Nature makes potatoes, not rulers, one of his colleagues famously tweeted. The natural origin camp countered just as fiercely. They proposed a new, exotic natural model of cosmic shard theory. Perhaps this was a fragment from a Pluto-like dwarf planet around another star, shattered in a cataclysmic collision, with a core of nearly pure carbon dioxide ice and a crust rich in nickel iron from its former core. The teardrop dust plume, they argued, was simply a jet of CO2 gas erupting from a weak spot in this strange crust, carrying the dark, metallic dust with it. The public fascination reached a fever pitch. The tracking 3I Atlas website saw traffic surge, crashing servers twice. Social media was flooded with artistic renditions of the shard, depicting it as everything from a crystalline seed to a ruined starship. A new wave of citizen science began, with amateur astronomers and data analysts scouring the publicly released light curve data, measurements of the object's brightness over time. It was this crowdsourced effort that uncovered the next bombshell. An amateur astronomer in Chile, comparing her own photometric data with the official records, noticed a tiny, periodic flicker. It was a pattern. Every 7.83 hours, the object's brightness dipped by a minuscule, but consistent, 0.2%. It was at the flicker in the data. After verification by professional institutions, the conclusion was inescapable: 3I Atlas was tumbling. But this was not a random, chaotic tumble. The period was too regular, the dip too clean. It was a slow, controlled roll. For the artificial hypothesis, this was the most compelling evidence yet. A derelict probe, its guidance systems dead, would slowly process as it traveled. A natural rock, shaped by eons of micro-impacts, would tumble erratically. The controlled roll was a hallmark of designed objects. The scientific pushback was immediate and intense. A team from Caltech published a complex model showing how a shard-shaped object with an off-center center of mass, heated unevenly by the sun, could naturally settle into a stable, periodic tumble. The debate was no longer just about composition, it was now about fundamental physics and intent. Amidst this turmoil, the daring plan for the Juno spacecraft gained new urgency. The Juno's gambit was approved. Using its last reserves of fuel, the Jupiter orbiter performed a precise, 3-minute engine burn. The maneuver was a success, subtly altering its orbit around the gas giant to position itself for a distant but crucial observation in a few months' time. It was a Hail Mary pass, a final attempt to get a unique dataset as the object departed. As the object receded from the Sun, its activity began to subside. The mysterious teardrop plume faded, and the faint ion tail dissipated. It was returning to the state in which it had arrived, a dark, silent, and enigmatic traveler. But it had left a transformed scientific community in its wake. The questions it raised would not fade so easily. Conferences were being planned for the next decade, dedicated solely to the analysis of the terabytes of data it had provided. Grant proposals were being hastily written to study hyperbolic objects and exocometary science. The final chapter of its direct observation was written by the world's most powerful radio telescopes. In a coordinated global effort, the Allen Telescope Array, the Green Bank Telescope, and others listened. They scanned every frequency, searching for any whisper of an artificial signal, a carrier wave, a pulse, anything emanating from the object itself. The result, announced after weeks of analysis, was a profound and resonant silence. There were no transmissions. No power signatures. No signs of life. This silence was, in its own way, the most haunting clue of all. It left humanity with two equally staggering possibilities. Either we had just examined a piece of naturally-formed debris from a planetary system so alien its very geology defied our understanding, proving the universe was even more creatively bizarre than we imagined. Or, we had just inspected a piece of discarded technology, a message in a bottle not meant for us, an artifact so advanced it was indistinguishable from a natural phenomenon to all but our most careful scrutiny. A relic whose makers, and whose purpose, would forever remain a mystery. 3I Atlas is now just a receding point of data, a blip on a screen growing fainter with each passing day. Its path is set. In a few years, it will cross the orbit of Neptune, and then Pluto, and then it will be gone, returning to the endless dark between the stars. But its legacy is permanent. It has shattered our parochial assumptions about what a comet should be. It has handed us a catalogue of anomalies that will fuel scientific inquiry for a generation. We reached out to touch a visitor from another sun, and in doing so, we touched the limits of our own knowledge. The greatest discovery was not an answer, but a beautiful, humbling, and eternal question, now traveling with the shard into the void. Thank you for watching. If you enjoyed this, please like and subscribe for more stories each week.